Today in the workshop, we're working with the microSD card on the ESP32-CAM module. We'll see how we can use the microSD card to store image data from the ESP32-CAM camera. We'll also build a motion-sensitive and time-lapse camera with our board. So smile for the camera, and welcome to the workshop. Well, hello and welcome to the workshop, and today we are back working with the ESP32-CAM board. Now, we've worked with this board a number of times before because it's such an amazing little board and an amazing little value. For about $10, you can get yourself a board that has an ESP32, which is a 32-bit microcontroller. It's got integrated Wi-Fi and Bluetooth capabilities, plus the board also has an onboard 2-megapixel video camera. And so by putting all of that together, we can build some pretty amazing projects. Well, one thing the board also has that tends to get neglected is it has a slot for a micro SD card. And we can use this micro SD card in our applications to store images from the camera, and that's exactly what we're going to be doing today. So let's go and take a quick review of the ESP32-CAM board, its onboard camera, and its micro SD card capabilities. The ESP32-CAM module is based around an ESP32-S 32-bit microcontroller. The board also has an OV2640 2-megapixel camera module. It has its own internal antenna plus provisions for an external antenna. The ESP32-CAM uses 3.3-volt logic. However, the board can be powered by either 5 volts or 3.3 volts as it has an onboard voltage regulator. On the front of the board, we can see the micro SD card, the camera, and a white LED that is used as a flash. Several of the connections to the ESP32 GPIO have been brought out for use in your experiments. There's also a connection for 5 volts or 3.3 volts in, as either can power the board. The VCC out is 3.3 volts and can be used for external peripherals. One thing that the ESP32-CAM does not have is a built-in USB port. You will need to use an external adapter or an FTDI adapter to program this board. Note that if you're using an FTDI adapter, you'll also need to jumper GPIO pin 0 to ground during the programming process. Despite its size, the ESP32-CAM board has a number of very impressive specifications. But perhaps the most impressive specification is the price. The board was initially offered at $9 and is now available for even less, often with the inclusion of an adapter board that contains an FTDI adapter. So let's go put this inexpensive module and its micro SD card to work for us. Now let's take a look at an ESP32-CAM module, and I've got one over here, and as you can see, it's a very tiny little module, and obviously the most predominant feature of it is the camera that's over here on the top, and it's actually on top of the micro SD card, which you can see over here. Now one thing is they don't have this mounted, it's just loose, so if I were you, I would put either a bit of hot glue or epoxy or maybe some double-sided tape over here to hold the camera down. I've done that on a few of my modules. On the front of the module, another thing that you might want to note is up over here, and that is an LED. This is a very bright white LED, and it can be used as a flash for the camera. Now, if we flip it over, you can see, of course, all the GPIO pins, but up in the corner over here, you'll see a little reset button, and you'll probably have to click that during the programming process, and you'll also need to click it in order to reset the board and get everything going. And another thing on this corner over here, we've got a tiny little connector, and that is for an external antenna. But if you want to use the external antenna instead of the built-in antenna, which you can see right over here on the printed circuit board, you're going to have to do a bit of soldering. You've got to remove the position of some tiny surface mount resistors over here. And if you take a look at my original video on the ESP32-CAM, you will see exactly how you can do that. Now, the other thing is that in order to work with this, you're going to need to use an FTDI card because, as you'll notice, this board has absolutely no connection for USB on it. And so you can wire an FTDI card up directly to the board. I'll show you how to do that. But another thing you could do is I built this a while ago. Now, this is actually an ESP32-CAM experimenter's module, and it has a place for the FTDI, which is in here right now. And you can see on the back it's also got a small solderless breadboard. It's got a built-in power supply, a 3.3 and a 5-volt power supply. And it's also hooked to this ESP32-CAM by the external antenna. You can see the external antenna over here. And in addition to letting you experiment with the camera board, it brings all the connections out over here. It also mounts the camera board so that it is actually facing in a more logical direction when you're experimenting with it. And again, you can go and see the video in the article about how to build that. There's another thing you can do that's a bit simpler, and there's these devices here. I just picked one up on Amazon, and let me take a look at this right now. It's an ESP32-CAM accessory board. It has got the FTDI adapter built onto it. It's got a micro SD port on it over here. It's also got two switches, a reset switch and a switch to IO pin 0. And you just plug your ESP32-CAM board into this. And one nice thing about this board is on the FTDI method, you need to go and jumper pin 0 and 1 whenever you're recording. In fact, that's why I've added a switch to my module over here just to make that process easier. But on this board here, you don't have to do that. You don't have to hit reset when you're uploading. You just basically upload. So it makes it a lot easier to use the ESP32. And I got this on Amazon along with an ESP32-CAM board, and I noticed quite a few selections of these. So you might want to look at getting something like that. But at any rate, that's the ESP32-CAM board, and today we're going to learn how to take images from the video camera and save them onto the micro SD card. Now, before we can start taking pictures with the ESP32-CAM and saving them to a micro SD card, there are a few things we need to take care of. And the very first thing, of course, is to get a micro SD card and to get it formatted correctly. After that, there's a couple of other things we're going to want to know. We're going to want to know how to work with a micro SD card within our programs, and it's pretty easy to do that. We're also going to want to know how to work with the video camera in our program, because naturally, if we don't know how to get camera data, we're not going to be able to save it. So let's start off by learning how to format the micro SD card that we're going to be using in the ESP32-CAM. Now, in order to perform these experiments, you're going to need to format your micro SD card in FAT32 format. And if you have a smaller micro SD card, and by smaller I mean a 4 gigabyte or maybe an 8 gigabyte micro SD, then it probably already is formatted in FAT32. Otherwise, you'll likely find that it's formatted in exFAT. Now, in order to format in FAT32, there's a number of different options. The majority of options are available for Microsoft Windows. Now, if the card is 16 gigabytes or less, Microsoft Windows File System can use its standard format utility to format in FAT32, although it will leave some volume information on the disk. That'll work for our experiments. Another way of doing it is with the Smart Disk utility, and this is a utility that we've used before with the Raspberry Pi, which also has a similar FAT32 file format requirement. Now, Smart Disk is a utility that Verbatim is distributing, and it's a free utility. There are a number of other utilities out there that are not free, but this is a free one, and it will allow you to format a micro SD card of pretty well any size with FAT32. Now, in order to use this, you need to have your micro SD card inserted first, so I've already done that, and I've opened up the Smart Disk utility. It says that I've got a 14 gigabyte card. It's actually advertised as a 16 gig, but that's pretty common. And I'm going to just hit Format Drive. Tells me I'm going to do this, and do I want to do it because I'm going to wipe everything out? I'll say yes. And there you go, the drive has been successfully formatted. So we've now formatted our microSD card with the FAT32 file system, and we can begin to use it in our experiments with the ESP32-CAM. In order to use a microSD card with the ESP32-CAM, it must be formatted with the FAT32 file system. The ESP32-CAM will address up to 4 gigabytes of space on the microSD card. You can use larger cards, but they will just be treated as 4 gigabyte cards. Internally, the microSD holder is connected to the ESP32's SPI bus. There are 2 libraries that come into play when programming for the microSD card. The FS library is the file system, and the SD_MMC library is the SD library for the ESP32. You'll begin our program by initializing the microSD. We'll then open a file up for writing. We'll write the file to the microSD card, and then we'll close the file. The camera included in the ESP32-CAM module is an OV2640. This module has a 1600 by 1200 sensor array. It uses a 1/4 inch fixed focus sensor. It has a maximum resolution of 1600 by 1200 at 15 frames per second. Internally, the camera is connected to the ESP32 GPIO. Most of the ESP32-CAM camera operation is controlled by the ESP_camera library. In your code, you'll need to define the camera pinouts and its connections to the GPIO, as different camera-equipped ESP32 boards utilize different connections. We'll then configure the camera parameters, and there are a vast number of parameters you can choose from to alter the image. You'll initialize the camera, and then you'll set up a frame buffer. Data from the camera will appear in the frame buffer, and you can read that data to use it in your code. So now let's start coding for the ESP32-CAM camera and its microSD card. So now that we've got the microSD card formatted, it's time to start working with the ESP32-CAM. Now our first project is going to be a basic camera. We're going to attach a push-button switch to the ESP32-CAM board, and we're going to use it to take pictures. So every time we press the button, the ESP32-CAM will take a picture and save it to the microSD card. So let's go and take a look at how we're going to hook that up. Now here's how we're going to hook up our camera project. We will of course require an ESP32-CAM module, and we'll need a push-button switch, a momentary contact normally open switch. Any style will work. We'll also be using a 10K pull-up resistor. We'll begin by connecting the VCC pin on the ESP32-CAM board to one side of the resistor. VCC is an output pin, and on the ESP32-CAM, it's been strapped to give an output of 3.3 volts, regardless of whether you're powering your camera with 5 volts or 3.3 volts. The other side of our resistor will go to one side of the push-button switch. We'll connect the other side of the push-button switch to one of the ESP32 ground pins. And finally, GPIO pin 13 will be connected to the junction of the switch and the resistor. And this completes our wiring. Now here's the sketch that we're going to use for our ESP32 camera, and this will allow us to save our picture data to the microSD card. Now we're going to start off by including all of the required libraries. So we start with the libraries we need for the ESP32 camera first. We also need some libraries for our microSD card. These are those. And we're also going to use a library for the EEPROM. And the reason we're using the EEPROM is we want to have a number that we can save in the EEPROM that we're going to use as part of the file name for the images that we save. And we're going to increment that number constantly. So we're going to save that into EEPROM, so every time we wake up we will know what the next number that we need to use is. Now we're going to only use 1 byte of the EEPROM, so we'll define the EEPROM size, and here is the variable that we're going to use for the picture counter, and we'll initialize it with a value of 0. Now the pin definitions over here are taken straight from the webcam server example, and it's for the AI Thinker camera. So I've only brought out the definitions for the camera that's on the ESP32 board, and this saves a lot of space in the code. Now, this function that we have over here is the first of a couple of functions. It's called config ESP camera, and this pretty well configures all of the camera parameters. And again, a lot of this has been just directly copied out of the camera web server example. This stuff has over here where we build a configuration object, and we just tell it where all the various camera functions are. And once again, this has been taken directly out of that example that was provided by Expressive. As was this over here where we set the frame size depending on whether or not that we support PSRAM. And over here we're going to actually initialize our camera. Now, this section over here allows you to do quality adjustments on the picture. And if you've used the webcam server example with the ESP32-CAM, and I'm sure you have, it's the first thing most of us do, you'll notice it has a bunch of controls on the front where you can set things like the brightness and the contrast and a number of special effects. Well, this is how you can do it programmatically. So every one of those controls is pretty well repeated over here. And what you could do is run the webcam server example, play with the controls with your camera to get the picture the way you want, and go back and set the values here. Right now everything is set to the default. Now the next function that we're going to look at is to initialize the microSD card, and essentially it just mounts the microSD card and detects that there actually is a card there and that it can verify its type, so a properly formatted microSD card. And the next function is the one we're going to use to take the picture. And we call it take new photo, and it needs one input, and that's the actual path or the file name of the picture. We're going to set up a frame buffer, and then we're going to pass that frame buffer over to the file system to build a file for our microSD card. And we're going to basically open the file, pass it to the microSD card, and then close it. So we're going to save the file, and we're going to return that frame buffer back for use by other processes. Now we're going to go into the setup, and setup is where everything runs, because we're running this sketch so that it's just going to wake up, it's going to take a picture, and then it's going to put the ESP32-CAM into a deep sleep. And by going into a deep sleep, we could probably save a lot of power if this was a remote battery operated type of affair. So we're going to start off first of all in our setup by just eliminating those nasty brownout detector messages with this line here. And then we're going to start our serial monitor so that we can view the activity, and we're going to be using the serial monitor when we run this. We'll initialize the camera by calling the config ESP camera routine, and then we'll initialize the microSD by calling the function we just showed you, init microSD card. And then we're going to initialize the EEPROM with the predefined size, which is only 1 byte, and we're going to get our picture count variable updated. And so we're going to read the EEPROM, and then we're going to add 1 to whatever the value is. So picture count is going to get incremented over here based on the value that we'd saved in the EEPROM. And then we're going to use that value to build the path that we are going to save our image at. And then we're going to take the photo. We're going to call take new photo and pass that path over to it. And once we've taken our photo, we need to update our EEPROM. And so we're going to write to the EEPROM with the new picture count. Now this is how we do the putting the microcontroller to sleep. This is where we bind a pin that when it's active, we will wake up the microcontroller. So we're binding GPIO pin 13, and the 0 over here means we're expecting a low input. So when GPIO pin 13 goes low, the microcontroller will wake up and it'll run whatever is in setup. And over here, once we've done that, we're going to print to the serial monitor that we're going to enter sleep mode, delay for a second, and then we're going to enter sleep mode over here. And this is how you put the microcontroller to sleep. So it's going to go to sleep at this point, and if it wakes up, it'll run everything that we just saw in the setup, which includes taking a picture. So when you start this, it's going to take a picture without you pressing the button, and then it's going to wait for you to press a button and wake it up on this pin to take another picture. Now there's nothing in the loop because everything runs in the setup. So let's load this up to our ESP32-CAM board and see if we can use our camera. So I've got the camera sketch loaded up to the ESP32-CAM, which I've got on my experimenters module, and I'll show you at the back of the module over here, it has a built-in push button, and that's what I've used in order to implement my own push button here. And so here's my 10K resistor up in there, if you can see that. And so when I press the button back over here, you'll see a little flash, and I took a picture. And if you look at my serial monitor, it says it's image number 3, which is correct because I've already taken 2 pictures with this. I can take another one. Maybe aim it up a little bit more so it has something more interesting to see. Take a picture of some of the equipment that's taking the video right now. And maybe a picture of myself. And another picture. And as you see, every time that I do, we'll see up on the serial monitor that I've got the picture listed, and then it says it's entering into the sleep mode because it's actually consuming very, very little current in between taking all of these images. And so it does seem to work. We can take a look at what we captured on the microSD card to see if any of these pictures actually came out. So here's the contents of our microSD card, and as you can see, I took a dozen pictures, and I'm sure many of them are absolutely horrible, but hopefully at least 1 or 2 of them came out. So let's take a look, and oh, we've got a picture of the wires that are on spools that are right above the drawers where I keep connector parts and things. So that's our first picture, and there's an overexposed version of it. And there's a picture of my arm and a little bit of test equipment behind it. And my stomach. Oh, there I am with some of the lights on the ceiling. There you go. There's one of the cameras that's taking the video that we can see, and also in the background some of my tools. So that one came out great. I'm going to maybe frame that picture. And that's an overexposed version of the above. And it looks like we got a lot of blank ones, and then we're back to the first one again. But we did manage to take some pictures with our ESP32-CAM camera that we built by just adding a push button and a microSD card. Now, after you play with the ESP32-CAM camera for a little while, you might want to reset your picture counter back to 0, and I wrote a little sketch that would allow you to do that. It's very simple. We just load the EEPROM library, we set it up the same way we did before to define a size of 1 byte, and then in the setup we'll open up a serial monitor. We're going to initialize the EEPROM library, then we're going to print the current value that we have inside there, so this will be the current value that we're holding for our picture counter, and then we're going to reset it by setting it back to 0, and we're going to print out that it's reset. So it's a pretty simple sketch. I've already uploaded it actually, so let me go and open my serial monitor, and let me just reset my board. And there we go. The current value was 18, and now it has been reset. I'm going to reset the board one more time. And the current value was 0. So reset did indeed bring it back to 0. So this is just a quick way that you can clean that out when you're experimenting with your ESP32-CAM camera. Now our next project is basically an extension of the previous project. We're going to take away the push button switch and we're going to replace it with an infrared proximity sensor. Now we've worked with these proximity sensors before, so as you know, when they detect infrared heat energy, such as that coming from a human being or an animal, they are triggered so they can be used to determine when someone has entered a room. We're going to have the proximity sensor trigger the camera and then take a picture, so you could use an application like this to monitor a controlled area or find out who's been eating all of your jelly beans. So let's go and see how we hook that up. We'll be building our motion-sensitive camera around an ESP32-CAM board. We'll also require a passive infrared or PIR sensor, and the one I'm using is the AM312. This is an ideal sensor as it is powered by 3.3 volts. However, you can also use an SR505 sensor if you wish. Now the SR505 needs a 5-volt power supply, but it will output a 3.3 volt logic level. We'll begin by wiring the supply voltage to our PIR sensor. If you're using the AM312, this means connecting this to the VCC pin on the ESP32-CAM board. If you're using the SR505, however, you'll have to find a 5-volt power source for it. We'll connect the signal out pin of our PIR sensor to GPIO pin 13. And finally, we'll connect the sensor's ground to one of the ESP32-CAM board's grounds. And this completes our wiring. Now we don't need to write a new sketch for our motion sensitive camera, as we can use the exact same sketch that we used for our basic camera. This is the sketch that will wake up the ESP32, take a picture, and then put the ESP32 to sleep. We do need to make one modification to the sketch for it to work, however, and it's down here on line 221. Let's move down there, and there we go. Now this is the line where we bind GPIO 13 to the wake-up call, and in our original sketch we looked for GPIO 13 going low, because when we pressed the push button we were connecting it to ground and sending the signal low. Well, in this case we want the opposite thing to happen. The PIR sensor will emit a high output every time that it detects the presence of someone, and so we want it to bind when it goes high and not low. So what you need to do is just change this 0 to a 1, because that's the purpose of this. It tells the ESP32 what sort of a signal to look for, a low or a high. So you want to change this 0 to a 1, and once you do that, you could load that back up to the ESP32, and we can check out our motion sensitive camera. And so here's my motion sensitive camera, and it seems to be working pretty good. Every motion I make around the workbench, it is taking a picture, and you can see that every time it does, it prints up on the serial monitor and then goes into sleep mode. So let me show you what I've got over here. This is the PIR sensor on the back, just on my little circuit board. And so every movement I've got around here is causing this to go and make a picture, which of course is exactly what we wanted to do in the first place. So as you can see, just a simple hardware change and one very basic software change has turned our basic camera into a motion sensitive camera. Now, time-lapse photography is a pretty interesting application, and we've worked with it before. When I did my 10th anniversary video for the Raspberry Pi, I included the time-lapse photography project in it. Well, we can also do time-lapse photography with the ESP32-CAM and the MicroSD card. Now, in time-lapse photography, what you do is you take an image and you take another image and you space them out at a predetermined time. And once you've gathered several hundred images together, you can stitch them together and make a movie. And in the Raspberry Pi project, we used a utility called FFmpeg to take all of our images and create a movie file. And we can do that as well with the images that we get from the ESP32-CAM. Now, naturally, the ESP32-CAM is a bit limited because it has a 2-megapixel camera, whereas the Raspberry Pi, you could use a variety of different cameras and different qualities. However, still with the ESP32-CAM, this could find practical application, such as just monitoring a secured area, or if you wanted to monitor a process such as a 3D print being built up. Now, we don't need to have any hookup for this project because we're simply just using the ESP32-CAM board by itself. So let's jump straight into the code that we'd need to use in order to turn our ESP32-CAM into a time-lapse photography unit. Now here's the sketch that we're going to be using with our time-lapse camera, and I think that you'll recognize a lot of the code in this sketch from the previous ones that we worked with today. Now we're going to start off by including the libraries for the camera and the libraries for the microSD card. Then we do the camera pin definitions for the AI Thinker camera, and then we set up a counter for our picture number so we can use that in the file name. And here is where we establish the delay time, the time between taking the pictures. So this is in milliseconds. So right now, every 10 seconds, our camera is going to take a picture. But of course, you could increase that or decrease that as your needs require. Then we're going to go through a number of functions that you've seen before. The config ESP camera that configures all the camera parameters. And again, if you want to adjust the picture quality, you can go through the section over here and change some of these values as you wish. The init microSD card initializes the microSD card, and the take new photo once again takes a picture and will pass it on to the microSD card. And so in our setup, we're going to disable the brownout detector, start our serial monitor, initialize the camera, initialize the micro SD card, and then to the serial monitor, we'll just print out what our delay time is so that we can remember how long it's going to be before we take a picture. Now we'll go into the loop and we'll establish what the file name is going to be for our new picture, and we'll print that to the serial monitor as well. And then we'll call the function to take a new photo, and then we're going to increment that picture count. There's no sense in saving this in EEPROM because we aren't going to be putting this to sleep. And then we finally just delay everything for the delay time. So it's actually quite a simple sketch. So let's load it up and take some time-lapse pictures. Okay, let's give our time-lapse camera a try. I'm going to plug it in here. And it seems to be taking pictures. Now it should do it every 10 seconds. So we'll wait for another picture. There we go. And if we look up on our serial monitor, we'll see that it's printing out that it's saved image 0 and now image 1. And basically we're taking pictures of me. I think that's what we're taking pictures of right now. And I set the timer, of course, to 10 seconds because it's a reasonable time for a demonstration. But in real life, you would probably want to set the timer for a much longer duration. A lot of time-lapse photography, you only take a picture every 10 minutes or something like that. It really depends what it is that you're monitoring. Monitoring me talking isn't going to be that particularly exciting, but as I said, it's just a demo. We're doing it for 10, but it does seem to be working. It's printing out on the serial monitor that it has been saving some pictures to our micro SD card, and it's taking pictures every 10 seconds, which is pretty well what it's designed to do. So as you can see, you can very easily turn your ESP32-CAM board into a pretty effective time-lapse photography device with just a bit of code and a micro SD card. And here are the images that we grabbed from the micro SD card. Now I've only allowed it to go through 9 of them, but they should be about 10 seconds apart. And we'll open them up, and well, that one looks a little on the purple side, as does that one. Well, that's a little less purple. And so basically photographs of me, photographs of the light on the ceiling of the workshop. Pretty exciting stuff. But as you can see, it does work. Our time-lapse camera with the ESP32 snapped my picture once every 10 seconds. So that brings us to the end of our look at using the ESP32-CAM to save data onto its micro SD card. But one thing I want to address right now is the subject of saving video. You'll notice that in today's video, all I've done is save images, and I haven't saved video. And you might be wondering why, because obviously we can stream video from this camera, so we know it's capable of video. Well, the answer is it's actually pretty difficult to save video, and the reason is that although the ESP32 is a very powerful processor, it does have its limitations, and the limitations have to do with both timing and with buffering data so that you can send it to the micro SD card while you're doing the video live. However, it isn't impossible to do that, and there are a number of programs on GitHub, including basically an ESP32-CAM VCR program, which has been forked about 14 different times, where people have attempted to do exactly this. Now, I tried tried a couple of forks of the program, and to be honest, I couldn't get it to work well enough to use it in a demonstration for today's video, but you might have better luck than I do. So I've included links to some of those projects in the article that accompanies this video on the DronebotWorkshop.com website. Now that article also has all of the code samples that I used from today's video, so you might want to go and grab those. And there's a link to the article right below the video. Now also, while you're on the website, if you haven't signed up to my newsletter yet, please consider doing so. It's not a sales letter, it's just my way of letting you know what's going on here in the workshop. And also, if you'd like to discuss this further, the best place to do that is on the DroneBot Workshop forum, where you'll find a bunch of like-minded individuals who love to talk about electronics, and membership to the forum, of course, is free as well. Now, finally, if you haven't subscribed to the YouTube channel, please do that. I love getting new subscribers, and I'd be honored if you'd be my next one. All you need to do is click on the red subscribe button, and also click that little bell notification, and assuming that you've enabled notifications on YouTube, you will get notified every time that I make a new video. So until we meet the next time, please take good care of yourself, please stay safe, and I'll see you again very soon here in the DroneBot Workshop. Goodbye for now.